Hi friends, see today I will be starting sound chapter, that is second year sound waves part 2. In part 1 we have discussed up to around almost phase and phase difference, okay, that is progressive wave equation, phase and phase difference. So in this part 2 of sound waves in second year physics we will be dealing about what are constructive super. I told you in the beginning only in last part 1, if you study well in this part 1, I mean part 2 or part 1, whatever thing sound, same concept again you will be using in light physical optics, okay, that is constructive superposition of light waves and destructive superposition of light waves, and those are very much useful for numerical problems. So please listen carefully, try to understand what is constructive and destructive superposition of sound waves. So let us discuss now constructive and destructive superposition of sound waves. Same thing again we will be learning in light waves. So ఈ constructive destructive superposition of light wave, I mean sound waves అంటే ఏంటి? See, it is very simple. For example, see this graph. Suppose one wave is going in this fashion, one sound wave, that is sine graph. Let this be y1 wave. Second wave is also going like this. For example, this is second wave. This is second wave. For example, this is second wave, y2. If you observe carefully, y1 and y2 waves are very near. That means their phase difference is 0. You can observe here. Phase difference 0. Again you can see the completion of wave here. And again they are starting from here. That means 0, 2 pi. Again you can see it. 0. It is ending the wave. Again next wave you can see it is ending here. So 0, 2 pi, again 4 pi. So if you observe carefully, that is y net. Y net is got by y1 plus y2. Are you following here? So in constructive superposition of waves, the resultant wave is nothing but y1 plus y2, because here you can see the resultant will be maximum. The resultant will be maximum y1 plus y2. So this is the resultant. By using principle of superposition of waves, the resultant is got by y1 plus y2 wave. You know what is sine wave? A sine omega t plus kx or k or omega t minus kx. I told you plus and minus. This is the equation. What is the equation? A sine kx plus minus omega t. Okay? So depending upon plus minus, minus means positive x direction. Both are same sign. Negative x direction, either minus or plus. If one is plus, another is minus, going in positive direction. So if you observe the two waves, here you can get the resultant is maximum. Okay. So for maximum constructive, what should we get the value here? The phase difference, if you observe carefully, starting from 0. Next again you can see pi plus pi, 2 pi. And next again you can see they're starting at here. See, ఇక్కడ 0 దగ్గర కలిసారు, మళ్ళీ ఎక్కడ, మళ్ళీ ఇక్కడ 2 pi, మళ్ళీ ఎక్కడ 4 pi, 2 plus, అంటే if you observe the series 2 pi, 4 pi, 6 pi, 8 pi, dot 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 2 and pi. In constructive superposition of sound waves, if you observe the series of these two sound waves, ఏంటిది, pi is equal to 0, 2 pi, 4 pi, even numbers are getting. And here n can take the value starting from 0, 1, 2, 3, so on and so forth. If you substitute here, n is equal to 0, 0 phase difference. Substitute 1, 2 pi, 2, 4 pi. So these are the values for constructive superposition of sound waves. In the same way I told in the last part how to calculate delta x. delta x is nothing but k into delta phi is equal to k in delta x, or what is k value here? K is equal to 2 pi by lambda. So delta phi is equal to 2 pi by lambda into delta x. So to get the path difference, okay, this is how much distance they are maintaining path. That is path difference between the two waves. Phase means at which state it is there. Both are in phase or out phase. Okay, so that is phase. So ఇక్కడ path difference ఎలా వస్తుంది? Delta phi into lambda by 2 pi is equal to delta x. So you can calculate for this constructive path difference. Put the value first one 0. 0 into lambda by 2 pi. So first one is 0. Again substitute 2 pi. 2 pi into lambda by 2 pi. Lambda. Next substitute 4 pi. 4 pi into lambda by 2 pi. 2 times 2 lambda. Like that, if you observe, you will get the series as 0, lambda, 2 lambda, 3 lambda and n lambda. So the path difference between the two sound waves here, y1, y2 is 0, lambda, 2 lambda, 3 lambda, n lambda. Here if you put values n is equal to 0, you will get first one 0. N is equal to 1 lambda. N is equal to 2 lambda. N is equal to 3. So n is equal to 0, 1, 2, so on and so forth. Clear? So these are the values you have to put it to get the path difference as well as phase difference for constructive superposition of waves. Clear? Superposition of sound waves. Clear? So these are very, very important in answering numericals for even advanced level IIT or in NEET and MSET questions. Clear? So this is the equation for phase difference and path difference. Now let us go to the next one, destructive. Destruction means down, sound waves are decreasing. Constructive means getting more, maximum value. Okay? So let us go for destructive. And again draw the figure for destructive. Superposition of sound waves. So destructive lo em jarugutundo okasari chuddam. Here small variation will be there. You can observe carefully. The next one is destructive. Destructive lo em jarugutundo chuddam. Destructive sound waves lo, if you draw the graph, see here, waves. For example, I will take this is the first wave. We will take this is the first wave. Second wave I will take in this fashion. Second wave I will take like this. So this is second wave. Now you can see the overlapping is like this. One wave is starting from here and one wave is in negative direction, positive waves. So here if you observe carefully, they are overlapping a distance of pi. First wave, it is ending here. Again they are overlapping at pi plus pi plus pi, 3 pi. Again 5 pi, odd numbers. So if you observe, the resultant will be littles, minimum. The resultant will be minimum. So here R is equal to y1 minus y2. The resultant is minimum. So if you observe here, the y net is equal to y1 minus y2. It is a breakup here, destruction. Okay, sound waves will be reducing. When it is super, the resultant will be reducing, destructive. So what is the phase difference? Actually start at pi, 3 pi, 5 pi, 7 pi, 2n minus 1 into pi. This is the series. Odd numbers. Put the value n is equal to, for example, 0, you try 0. If you try 0, what happens? If you try 0, this 0 minus avutundi. So 0 నుంచి start చేయకూడదు. n is equal to 1 నుంచి start చేయాలి. If you put n is equal to 1, 2 1s are 2, 2 minus 1, 1, 1 into by pi. n is equal to 2, 2 to the 4 minus 1, 3 pi. So 1, 2, 3, 4 dot dot dot. So n can take the values for destructive sound waves starting from n is equal to 1 here. 1 పెట్టండి, not 0 here. So because otherwise you will get minus pi. So 1 పెడితే ఇక్కడ ఏమవుతుంది? 2 into 1, 2, 1, 2 minus 1, 1, pi, 2, 4 minus 1, 3. So this is the series. In the same way, for this path reference also you can calculate. What is the path reference? Delta phi is equal to 2 pi by lambda into delta x లేదా delta phi into lambda by 2 pi is equal to delta x. So at the path reference, how much distance they are maintaining? So for first case, delta x ఎంత అవుతుంది? Pi పెట్టండి. Put the value pi into lambda by 2 pi. What is the value you are getting? Lambda by 2. Same these things again you will be using in light chapter, physical optics. Okay? In finding the fringe widths. In finding the fringe widths, dark and bright bands lo you vadukuntamu. So please listen carefully. If you understand better, there again you can use in constructive and destructive superposition of light. So first one is lambda. Second one in the 3 pi. 3 pi into lambda by 2 pi. Pi gets cancelled. 3 lambda by 2. You can observe the series again. Next one in the 5 pi into lambda by 2 pi. That is 5 lambda by 2. Observe the series here. You are getting lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n plus 1 into lambda by 2. So here if you observe carefully the series, lambda by 2, path reference between the two waves, y1, y2, sound waves, 3 lambda by 2, 5 lambda by 2. Last ఎంత అవుతుంది? You are getting 2n plus 1 into lambda by 2. We will try to put the values. For example, if you put 0, then what happens? Lambda by 2 వచ్చింది. అదే మైనస్ ట్రై చేస్తే ఏమవుతుంది? మైనస్ ట్రై చేస్తే మైనస్ పెట్టండి. అప్పుడు 0 పెడితే ఫస్ట్ వస్తుంది. బాగానేనా? వస్తుందా? చూడండి. సపోజ్ ఇఫ్ I'll try to put minus 2n minus 1 into lambda by 2. When I put 0 here, what happens? 0 ఇది మైనస్ అయిపోతుంది. So this is not valid. 2n plus 1 తీసుకోవాలి. If you put minus చెల్లదు, అవ్వదు అక్కడ. So 2n plus 1 into lambda by 2 is the exact one. Now put 0, lambda by 2. n is equal to 0 పెట్టండి. Put n is equal to 0, lambda by 2. n is equal to 1, 2 plus 1, 3 lambda by 2. n is equal to 2 to the 4 plus 1, 5. n is equal to 3, 3 to the 6 plus 1, 7, lambda by 2. So like this you can put the values for destruction of sound waves. Clear? These are very, very, very important regarding numericals. And same thing again I will be repeating in physical optics for fringe widths. Okay? Right. And that is in Young's double slit experiment. As fringe widths lo ivanni vaadtam manam. Clear? Right. So this is about the constructive and destructive superposition of sound waves. Very, very important thing. Now let us go still further in this one. Very, very important topic, next one, that is, okay, the next one will be dealing, that is very, very important one, that is nothing but equations for stationary, standing waves, stationary or standing waves. Now let us study about the equations, mathematical equations for stationary or standing. That means which is not moving. Wave is not moving with velocity. Okay? Wave కదలట్లేదు, అక్కడే ఉంది. It is not having any velocity. It is standing there. Stationary. That is the meaning of stationary or standing wave. Now let us see how this wave is formed, and due to this resultant, what are the things formed resultant. దీని ఫలితంగా మనకి ఏవేవి ఫామ్ అవుతున్నాయి ఇవన్నీ కూడా నేర్చుకుందాం. బికాస్ దీస్ ఆర్ వెరీ, వెరీ ఇంపార్టెంట్ సాల్వింగ్ న్యూమరికల్స్ ఇన్ అడ్వాన్స్డ్ లెవెల్, నీట్ అండ్ ఆల్సో ఎంసెట్ లెవెల్. సో ఫస్ట్ ఆఫ్ ఆల్, వాట్ ఈస్ a stationary wave? See, this is one progressive wave. For example, say y1, and this is another progressive wave, say y2. So these two are superimposing. For example, these are superimposing. Both are traveling in the same medium with same amplitude and frequency. This is one wave. This is one wave. Let y1 is equal to a sin kx minus omega t, going in this direction positive. Let another wave y2 is equal to, just now I told you, both waves are having same amplitude and same frequency, traveling in the same media, superimposed. The resultant wave is called as, or formed as, stationary or standing wave. So another one is sin kx plus omega t. Whenever you are getting kx plus omega t or minus omega t, that wave is moving. If you are not getting kx plus or minus omega t, that is wave constant or wave whatever k, propagation wave constant, okay, and omega angular frequency, ఈ ఐటమ్స్ ఉంటేనే ఆ వేవ్ మూవ్ అవుతుంది, అదర్వైజ్ ఇట్ ఈస్ స్టాండింగ్ వేవ్. ఓకే, నౌ దీస్ టూ వేవ్స్ ఆర్ మూవింగ్ నౌ, దట్ ఈస్ వై ఐ టేకెన్ kx minus omega t, ఫార్వర్డ్ x ప్లస్ omega t ఆపోజిట్. సో దీస్ టూ ఆర్ సూపర్ ఇంపోజింగ్ నౌ. ఇలా సూపర్ ఇంపోజ్ అవుతున్నప్పుడు మనకి what is the resultant you are getting? We'll see by using principal superposition. Y net is equal to y1 plus y2 by using principle of superposition, adding both these waves. ఏమవుతుంది? A sin kx minus omega t plus A sin kx plus omega t. So you can observe carefully this one, y resultant or y net. If I take common, I can write in this fashion: A sin kx minus omega t plus sin kx plus omega t. If you observe this one in trigonometry, it is sin c plus sin d. In mathematics trigonometry, it is in the form of sin c plus sin d form. 2 sin c plus d. 2 sin c plus d by 2 into cos c minus d by 2. In trigonometry, we have a formula. If you observe carefully. Okay? So, this formula ఉంది, sin c plus sin d formula trigonometry లో. దాని ఫార్ములా ఏంటి? 2 sin c plus d by 2 by cos c minus d by 2. Apply here. So, y net resultant is equal to A common 2 sin c plus d, that is kx minus omega t plus kx plus omega t by 2 into cos c minus kx minus omega t plus kx plus omega t by 2. Clear? So I applied the formula here, sin c plus sin d. So ఇక్కడ ఏమవుతుంది ఫైనల్గా, you are getting as y resultant is equal to A common 2 into here, when you are adding minus omega t plus omega t get cancelled, kx plus kx, 2kx by 2. I write it here, sin 2kx by 2, 2 gets cancelled into cos. Here you can see here also, ఇది మైనస్ కాబట్టి లోపలికి వెళ్ళినప్పుడు you can, I'll write it here. Okay, otherwise I have to write one more step. I'll write here kx minus omega t. Okay, 2 sin c plus d by 2, sin c minus d by 2, c minus ఇది. Okay, c ఇది minus, not plus there, c minus. Okay, 2 sin c plus d by 2 into cos c minus d by 2, c minus d by 2. c minus లోపలికి వెళ్తున్నప్పుడు we'll get minus kx and minus omega t by 2. So if you observe carefully here, plus kx minus kx cancel, minus omega t minus 2 omega 2 by 2, minus 2 omega t by 2. Here also 2 gets cancelled. Clear? I will write the steps again on the top. I think I cannot see. Please copy meanwhile. This derivation is also important for understanding the standing wave. Now see, so as I said just now, two progressive waves having same amplitude and frequency, traveling in the same medium, superimpose, then the resultant wave formed is called as stationary standing. So finally wave వచ్చింది మనకి y net I got it as A into ఇక్కడ 2 sin ఇదెంతది kx into here 2 to get cos of minus theta in trigonometry again, you know cos theta, cos of minus theta, you know in trigonometry again, cos of minus theta is equal to cos theta. So negative value it becomes positive. So cos omega t. So finally ఏమొచ్చింది ఈక్వేషన్ మనకి y net. చూడండి ఒకసారి అబ్జర్వ్ చేయండి, resultant wave ఏర్పడింది, ఏమైనా ఏర్పడింది when they are superimposing two progressive waves. I got it as 2a sin kx cos omega t. You observe carefully in this equation, do you have kx minus omega t or kx plus omega t? You are not having. In this equation, you are not having kx minus or plus. When you are not having this term, the wave is not moving forward, this direction or this direction. So it is still. That means it is standing, stationary, standing by stationary wave. Therefore, this equation indicates a stationary wave or standing wave equation of the progressive wave. If you have this equation, then it is moving in forward or in backward direction. Because you are having in this form, it is a standing wave. Clear? Please note down. Very, very important equation. Very, very important. Now, you can also understand this equation in different forms. Stationary wave, any forms lo untundi equation, that also you have to understand. The stationary wave can be in different forms. See, this is the original equation. Same equation I can write in different form. Different form and enti 2a sin kx cos omega t. This is one form. We will see the second form. Y is equal to 2a sin kx sin omega t. Both can be sin. And again, y is equal to 2a. I can write here cos x cos omega t. Third form. And last form 2a cos. Okay? You చూడండి ఒకసారి 2a sin kx cos omega t, 2a sin kx sin omega t, అలాగే 2a cos x, okay, cos omega t, అలాగే 2a cos x sin omega t. All these four equations represent standing wave or stationary. చూడండి, you can write in any fashion. 2a sin kx cos omega t, 2a sin kx sin omega t, 2a cos kx cos omega t, అలాగే 2a cos kx sin omega t. In any way you can write either cos x sin omega t, cos x cos omega t, sin x sin kx sin omega t, అలాగే sin kx cos omega t. These all equations represent your standing wave or stationary wave. Clear? Please note down. Any of the equation is right. And please make a note, these equations doesn't have kx plus or minus, therefore the wave is not moving. It is stationary. It is stationary. Not only that, you can also draw a graph for this wave and you can try to explain. ఈ వేవ్కి ఒక గ్రాఫ్ కూడా డ్రా చేసి మీరు ఎక్స్ప్లెయిన్ చేసుకోవచ్చు. అంటే see like this. You can draw a graph. In what fashion? For example, time t, you can start from 0. You can start from 0, t by 4, t by 2, 3t by 4, and finally t. You can give the values at the time t is equal to 0. Okay, t by 4, t by 2, 3t by 4, like that you can give these values for this one and you can fix a graph here. For example, see in this equation, y is equal to 2a sin kx cos omega I can write as 2 pi by t into t. At time t is equal to 0, put 0. 0 into this one, cos 0 anta? Since cos 0 is equal to 1, this entire time will go and finally y is equal to 2a sin kx. So at time t is equal to 0, for example, t is equal to 0. So the graph will go, it's a positive, you can see. So this is for what? Y is equal to 2a sin kx. So you can observe carefully, these particles are standing here. There is no movement for these particles. These particles, they won't move, they are there only. Okay? Only these particles will be moving, you can see. Only they are moving like this. Again, same way, coming down. Okay, again. going up again, coming down again, going up. But if you observe here at the junctions, these are also called as nodes. They won't move at all. Displacement is 0. These are also called as nodes. These are also called as nodes. No displacement. There will be like a security guard there. They will be stopping the wave not to come this side. They will be obstructing. So, ఈ wave అక్కడే మూవ్ అవుతుంది అలాగా. ఈ wave అక్కడ, ఈ wave ఇక్కడ. అదవుతుందా? Like this they will be moving in same place. They won't move because it's a standing wave. And these are security guards, nodes. They will be stopping the wave in forward direction, not to move. Okay? So, this is for if you give time is equal to 0. Again, you can go for t by 4. Substitute here. You can go y is equal to 2a sin kx cos 2 pi by t into t by 4. T cancel 2 1s are 2 pi by 2. అంటే cos 90. Cos 90 is 0 కాబట్టి ఇదంతా 0 అయిపోతుంది. So it is nothing but a straight line. This graph you can see t is equal to t by 4 straight line. All are in a straight line now, no wave. Okay, and this is what? Y is equal to 0. Same way come to the next one, t by 4. Y is equal to 2a sin kx cos 2 pi by t into ఇందాక ఎంత పెట్టారు t by 4 కదా ఇప్పుడు t by 2 పెట్టండి t cancel cos pi minus 1 so this will become minus y is equal to 2a sin kx cos 180 minus 1 so minus so this graph is what minus y is equal to minus 2a sin kx so it will start from down okay so it will be starting like this okay now you can see the particles will be in this fashion you can draw the graph very easily okay and these are security guards they won't move they will be protecting the wave not to move forward and those are called as nodes they will be stopping the wave not to move forward negative and last again you can see when substitute when substitute t by 2 you can again substitute 3t by 4 okay I'll rub that one so like this you can form the graph here okay 2a sin kx cos omega t you have drawn 3 points now time is equal to 0 t by 4 t by 2 you can also find out for 3t by 4 you can also find out for 3t by 4 t is equal to 3t by 4 that is 2 sin 2a sin kx cos omega 2 pi by t into t 3t by 4 3t by 4 t cancel okay 2 1s are 2 2s are time ఎంత ఇక్కడ 3t by ఫస్ట్ ఎంత చేసాం మనం వాల్యూ 0 t by 4 t by 2 half 3/4 t by 4 okay next finally t so 3t by 4 వేస్తే tt gets two cancel ఎంత ఉంది ఇక్కడ మనకి 3 pi by 2 3 pi by 2 ఎంత 270 pi by 2 అంటే 90 కదా అంటే 270 what is cos 270 again cos 180 plus 90 so cos 180 plus theta again cos theta cos 0 again this becomes entire 0 again 0 again straight line again y is equal to 0 see positive 0 negative 0 again you can substitute one more value last value t again substitute t so that will be last one y is equal to 2a sin kx cos 2 pi by t into t cancel cos 360 degrees again cos 360 అంటే ఎంత మళ్ళీ చూడండి 270 plus 90 2 pi కదా 360 అంటే ఇక్కడ చూడండి ఇక్కడ చేస్తున్నాను మీకు ఫోర్త్ క్వాడ్రంట్ Okay, so this is the trigonometry circle. First, second quadrant, third one, fourth one. 90 plus theta, second one. 180 plus theta, third one. 270 plus theta, this is 180 plus theta. 180 plus theta means third one. 270 plus theta means fourth quadrant. Fourth quadrant lo cos theta and secant theta are positive. So cos 270 plus theta, fourth quadrant. So fourth quadrant lo cos 270 plus theta ante sin 90. Sin 90 lo cos again positive kada. Chudandi. Cos is positive. Cos theta and secant theta. So sin 90 malli 1 ikkada. So malli manaki value positive value vastundi. Inko graph. And y is equal to a sin kx. Malli manaki ila vastundi. So in this fashion, the wave will be dancing there itself. It won't move forward because these nodes will be stopping. They are acting like a security guards, protection. So hence, this wave without kx minus or plus omega t, it is a standing wave or stationary wave. Please note down. These are very, very important explanations. Clear? Now, we will try to do a small numerical. We will try to do a chinna numerical or shade and try chedam problem so that you can understand better manner. So I think it is very clear all of you the subject regarding the stationary wave or standing wave. Now see here carefully, one thing it is very clear from this experiment, that is we have learnt about, see, suppose the waves are forming like this. It is very clear. So this is node, 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 node and node. These nodes are protecting the waves not to go forward, and during these you are also having antinodes, antinodes, antinodes. Okay? So these nodes are having minimum displacement. That means amplitude is 0. Nodes are having minimum displacement. Antinode, amplitude is 0. And antinodes, if you observe carefully, antinode, maximum displacement from the main position. That is called the antinode. Okay? And not only that, you can see distance between two successive nodes. Two successive nodes is lambda by 2. Distance between any two successive nodes is lambda by 2. Or distance between node and next antinode, lambda by 4. And distance between antinode and next antinode, lambda by 4 plus lambda by 4, again lambda by 2. These are some properties you have to remember. These are important in doing numericals. మీకు అర్థమవుతుందా? ఈ నోడ్స్ ఫామ్ అవుతున్నప్పుడు నోడ్కి మధ్యన దూరము lambda by 2, నోడ్కి యాంటీనోడ్కి మధ్యన దూరం lambda by 4, and two successive nodes or antinode distance is lambda by 4. So for antinode the displacement is maximum, and for node the displacement is 0 displacement amplitude. Now we will do one problem to understand better manner this one, and then we can go forward in the subject. A problem ఏంటో ఒకసారి చూడండి. I will give a small numerical for you for understanding a better manner. That is, a wave is given like this stationary wave. I told you in stationary standing wave kx minus omega t or plus omega t will not be there because it's not going. So what is the standard equation? First of all, 2a sin kx cos omega t or sin x sin kx sin omega t రాయొచ్చు, లేదా 2a cos kx cos omega t, or you can interchange. So this is standard equation. Now he is giving one equation as y is equal to a sin, y is equal to a sin 200 t, y is equal to 200 t cos 0.1x, 0.1x. I told you the equation you can change any fashion. Okay, cos omega t, okay, sin omega x, ఎలా రాసుకోవచ్చు. You can change this one, kx cos omega t, లేదా ఇక్కడ రెండు కాస్లో కూడా రాసుకోవచ్చు, ఎనీథింగ్ అండ్ చేంజ్. Here he is given as y is equal to a sine 200t into cos 0.1 k 0.1 x ఇచ్చాడు. సో ఇది ఏ ఫామ్ లో ఉంది మనకి జాగ్రత్త చూడండి. దిస్ ఈజ్ ద ఫార్మ్ ఆఫ్ సైన్ ఓకే, దిస్ ఈజ్ ద ఫార్మ్ ఆఫ్ ఒమేగా టీ. ఇది kx ఫామ్ లో ఉంది. సో యూ కెన్ చేంజ్ దిస్ into standard form. He is asking you what is wave velocity. What is wave velocity? I told you either you can formula, you can write n lambda or omega by k, coefficient of t by coefficient of x. Coefficient of t ఎంత ఇక్కడ 200 by coefficient of x ఎంత 0.1. Remove the decimal, transfer the 10 to top. So 2000 or 2 into 10 cube meter per second. This is how you will calculate the wave velocity. Okay? And this one is amplitude. If you ask the question in this fashion, very easily you can answer the problems. Okay? Na? Right. Please note down. We'll go to the next one now. Now let us do some more extension things in this one. That is fundamental note, fundamental frequency of a stretched string. Okay? We already learned the velocity of the stretched string. Velocity root over t by m, where m is linear density, t is tensor. Now suppose if a string is there, okay, suppose if a string is there, okay, now we know these are the segments here. For example, two points are fixed here. Now suppose like this it is formed. That means here how many nodes? 2 nodes are formed. So between two fixed points of the string, 2 nodes and 1 antinode. Between two fixed nodes lo 2 nodes oka antinode form. దీన్నే segment అని కూడా చెప్పు. This is also called a segment. One segment. ఒక segment లో ఎన్ని nodes form అవుతాయి? See, in one segment n plus 1 nodes are formed. N plus 1, please remember, nodes are formed. In one segment, how many nodes you can see? N plus 1. అంటే segment plus 1 అంటే 2 nodes. For example, 2 segments. Let us assume 2 segments. 2 segments అంటే just చూసుకోండి. This is one, this is another segment. So in 2 segments, how many nodes are formed? 2 plus 1. 2 plus 1 nodes. See, 1, 2, 3. 3 nodes are formed. Okay, are you following here? And for n segments, nth segments, how many nodes are formed? N plus 1. Okay, n plus 1. Are you following this point? This formula is very, very important in solving numericals. Now for first one we'll solve. Let the length be L. Okay. Just now I told you property. What is the distance between node and node? Distance between node and node is given by lambda by 2. Node and node ki madhya dooram enta? Lambda by 2. Or lambda is equal to 2L. So we know V is equal to n lambda. Therefore V is equal to n into 2L. So V by 2L is equal to n. This is also called as fundamental node, fundamental frequency of the stretched string for one segment. For first segment, fundamental frequency లేదా fundamental node for one segment. అలాగే 2 segments వస్తే ఎంత అవుతుంది చూడండి. For 2 segments, what is length? Lambda by 2. So what is length now? Lambda by 2 plus lambda by 2. Lambda. So what is V velocity? V is equal to, I'll put it as n1 here. n1 into lambda. Okay, lambda and length L. So V by L is equal to n1. Now I'll multiply and divide with 2. So what is now this one? V by 2L is fundamental node. Okay. So appudu ఏమైంది? n1 is equal to 2 times of n. n1 is equal to 2 times of n. And this is also called as in terms of harmonics, second harmonic. In terms of harmonics, you can also call it as second harmonic. In the 2 times వచ్చింది కాబట్టి fundamentally. అలాగే if you go for third one, 3 segments చూడండి, 1, 2, 3, lambda by 2, lambda by 2, lambda by 2. How much length? 3 lambda by 2. So what is the lambda? 2L by 3 is equal to lambda. So from this, what is velocity? V is equal to n into lambda, n into 2L by 3. So this I can write as 3V by 2L is equal to n. Again observe, V by 2L. So V by 2L is coming constantly. It is fundamental note or fundamental frequency. 3 times. N3 is equal to 3 times. So this is also called a third harmonic. Continuously it is coming, see, n. And you ratio got chudandi, 1:2, 2:2, 3:2, 4:2, so on and so forth. Chudandi, 1:2, 2:2, 3:2, 4:5. So this is the ratio for the stretched string for first segment, 2 segments, 3 segments, 4 segments, or even you can extend the segments. And thereby you can do numerical problems. Clear? Any doubts? See, these are very important while solving problems. Okay na? Abdoutundi meeku? These are also called as harmonics. Harmonics ki overtones ki data enti cheppandi. What is the difference between harmonics and overtones? What is the difference between overtones and harmonics? In general, what we say is harmonics minus 1 is called as overtone. In general, what I will tell is harmonic minus 1 is treated as overtone, number of overtone number. In general, I will tell harmonic, for example, in general, say second harmonic. So minus 1, this is called as first overtone in general. But in some case it is not equal. Because next when we study about organ pipes, in organ pipes, for example, in closed pipe it is not same again, because in that second and other harmonics are escaping, they won't come there like this regularly. So here harmonic overtone different, second harmonic and minus 1 first overtone, alage third harmonic minus 1, it is called a second overtone. Third harmonic or second, alage fourth harmonic third overtone minus 1, fifth harmonic minus 1, fourth overtone. So like that you can differentiate. But don't think it is always right. Just now I told you, in pipes it will be different again. Change will be there for closed pipe, not for open pipe. Open pipe it is okay. For closed organ pipe it is again different. Clear? And one more thing I have to tell you. Please copy fast. One more thing, very important. For example, see here, I am trying to give a small problem. For example, see here, a string is divided into 3 segments, 1, 2 and 3. For example, a string is divided into 3 segments. Segment 1, 2 and 3, and is given distances, say S1, S2, S3. That means lengths. He is given the lengths as not L1, L2, L3. I am changing. He is given as S1, S2 and S3, and the total length instead of L I am taking it as S. I am not using the regular things. Total length is S, and first segment length is S1, second segment S2, third S2. And he has also given the frequency for this one as N1, N2, N3. Now he is asking you to find some relation. Relation adugutunnadu. A relation iti chuddam. Okay? Let us find some relation. Let us find some relation for this numerical. ఇక్కడ జాగ్రత్త చూడండి. ఫస్ట్ పెద్ద స్ట్రింగ్ తీసుకుందాం ఇక్కడి నుంచి ఇక్కడికి. We know V is equal to n lambda Okay na? And what is length here? Lambda. Yes. And not only that, from mathematically, what is S? Total length S I can write as S1 plus S2 plus S3 mathematically. Total length S I can write as S1, 3 segments length. Okay, you can see your nodes 1, 2, 3, 4. Just now I told you how many segments are forming. That segments plus 1. Those are number of nodes. Nodes ఎప్పుడు కూడా +1 ఉంటాయి నోడ్స్. అలాగే యాంటీ నోడ్స్ చూడండి 1, 2, 3. ఓకే 1, 2, 3 సేమ్ యాంటీ నోడ్స్ 1, 2, 3. ఓకేనా? ఎన్ని నోడ్స్ ఉంటే ఇక్కడ చూడండి -1. ఎన్ని నోడ్స్ ఉంటే -1 యాంటీ నోడ్స్. ఇక్కడ 4 నోడ్స్ ఉన్నాయి -1 3 యాంటీ నోడ్స్ 1, 2, 3. Now see here S is equal to S1 plus S2 plus S3. Now what is S here? The total length, wavelength. So V is equal to, if n is the frequency, n, what is the total wavelength? Yes. Okay na? What is the total wavelength? Yes. Now from this I can take what is n? I can take like this, V by S is equal to n. Or else I will do one thing, V by n I will put it, because here the relation is S. Relation S undi kabatti I will put as V by n. V by n is equal to S, equation 2. Alage if you go for the first segment, V by n1 చూడండి కావాలంటే ఫస్ట్ సెగ్మెంట్ ఎంత lambda by 2 కదా, lambda by 2 lambda by 2 lambda by 2. ఓకేనా? సో lambda by n ఎంత లెంత్, lambda by 2 is equal to S1 or lambda is equal to 2S1, but we know V is equal to n into, okay, ఇది n1 కదా, n1 into lambda, that is 2S1. So from this what is S1 here? V by 2n1 అంతే కదా S1. What is S1? V by 2n1. In the same way S2 ఎంత అవుతుంది? S2 కూడా V by 2n2, S3 V by 2n3, and this is equal to S. What is S? V by n. V by n. Now overall V is common, you can take out. So 1 by n is equal to 1 by 2n1 plus 1 by 2n2 plus 1 by 2n3. Is it right? See here? Here also you can see total length. What is total length? This one. S is equal to S1 plus S2 plus S3. ఇది ఎంత మొత్తం? టోటల్ లెంత్ ఎంత మొత్తం? lambda by 2 plus lambda by 2 plus lambda by 2 ఎంత? 3 lambda by 2 is equal to total length ఎంత? S. ఓకేనా? So from this what is lambda? 2S by 3. So V is equal to n lambda, n into 2S by 3. లేదా 3V by 2S is equal to n. Okay? Or you can take like this, 3V by 2n is equal to S. So why I am telling this one is, this is a small related problem to understand the strings. ఇక్కడ మొత్తం S ఎంత అవుతుంది? S1 plus S2 plus S3. But what is S? Total length. Total length. Total length ఎంత ఇది? Lambda by 2 plus lambda by 2 plus lambda by 2. 3 lambda by 2. 3 lambda by 2. V is equal to n lambda. V is equal to n into lambda. Lambda ఎంత అవుతుంది ఇందులో? 2S by 3. So from this what happened? 3V by 2n. 3V by 2n is equal to S. సో ఇక్కడ అలా సబ్స్టిట్యూట్ చేసి కూడా చేసుకోవచ్చు. ఇక్కడ ఈ ప్లేస్లో 3V by 2n. అప్పుడు మీకు ఏమవుతుంది? 2 కూడా క్యాన్సిల్ అయిపోతుంది. 2 కూడా క్యాన్సిల్ అయిపోతుంది. V అలాగా క్యాన్సిల్ అయిపోయింది. 3 మిగులుతుంది పైన. 3 is equal to 1 by n1 plus 1 by n2 plus 1 by n3. So just for an example I have given this problem to understand better manner. Okay, to understand in a better manner. Clear? Right? Now this is how the stretched string problems are done in the examination. Now one more point is left over. I will complete it within 5 minutes. That is sound wave speed. Speed of sound wave, that is speed of longitudinal wave. How it is calculated and what are the theories regarding this one. Okay. So next one is speed of the sound waves. So let us see the things, how to calculate the speed of sound. The speed of sound, that is longitudinal waves. Longitudinal waves. We know it is longitudinal progressive and its displacement is parallel, okay, to the propagation of the wave, and already I have given the equation part 1 also. So to explain this one, generally speed, that is velocity, is given by root over E by D. Here E is called as elasticity of the medium and rho density of the medium. Density of the medium. So velocity of sound, speed of sound is given by root over E by D. Elasticity of the medium and rho is the density of the medium. This is general formula. This is general formula. And we all know velocity of sound is more in solids and then in liquids, okay, and then in gases, or gases less than, liquids less than solids. అంటే సాలిడ్స్లో సౌండ్ బాగా ఎక్కువ, లిక్విడ్స్లో కొంచెం తక్కువ, గ్యాసెస్లో మరీ లీస్ట్. అదవుతుందా? ఆర్ గ్యాసెస్ లెస్ దెన్, లిక్విడ్స్ లెస్ దెన్ సాలిడ్స్. అంటే ఈ ఈక్వేషన్ బట్టి ఏం తెలుస్తుంది? వెలాసిటీ ఆఫ్ సౌండ్ ఈజ్ మోర్ ఇన్ సాలిడ్స్, నెక్స్ట్ ఇన్ లిక్విడ్స్, నెక్స్ట్ ఇన్ గ్యాసెస్. సో బికాస్ గ్యాసెస్ are very, gap is there between molecules, distance is more, whereas in solids it is tightly packed. Now to explain this one, two scientists came forward. In that, the first person is Sir Isaac Newton. Okay, Sir Isaac Newton. So what does Newton told to explain the velocity of sound? Newton considered isothermal expansion. Isothermal expansion. Newton and scientist ఏం చేశాడు? To give the equation, he has considered isothermal. That means temperature constant, like Boyle's law. So keeping temperature constant, he has given equation as V is equal to root over E by rho low. E is the elasticity of medium. E is the elasticity of the medium. But here what happens in gases? Gas molecules. Okay? In gas molecules, E is taken as B. This is also called as bulk modulus of elasticity. This is also called as bulk modulus of elasticity. B is called as bulk modulus of elasticity. అదవుతుందా మీకు? ఇది already I have used in, I think, in thermal expansion of solids, I think. Okay? Young's modulus and other things I have used this term. Bulk stress to bulk strain. Bulk modulus is equal to. So for gas molecules, V is equal to root over E by D or rho. E is the elasticity. So E బదులు మనం ఏ యూజ్ చేస్తాం? బల్క్ మాడ్యులస్ B యూజ్ చేస్తాం. అప్పుడు ఫార్ములా ఏమవుతుంది? V is equal to root over B by rho. B by rho for gases. For gas molecules, B is bulk modulus velocity and rho is the density. So what Newton has considered is taking the, for example, the pressure. What you take here? I'll change the equation here for calculation purpose. This bulk modulus of gas, see here, this B is nothing but pressure, that is pressure of air. Generally it is taken as 10 power 5 pascals. Okay, and rho, density of air, it is taken as around 1.29 kg per meter cube. So bulk modulus and ఏంటి gas ది? Generally it is taken as P, pressure of the air, 10 power 5 pascals, and rho density 1.29. Okay, so are you understanding the point here? Here B means the bulk modulus. Okay, So in isothermal expansion, B, okay, because temperature is constant here. So B is equal to P pressure, that is P of air. Okay. Therefore, if you substitute the values here, according to Newton's equation, if you substitute here, pressure 10 power 5 pascals by density 1.29 kg per meter cube, this value was found to be very less. I think around 280. Yes, around 280 meters per second. So that is why some defect is there in Newton's explanation. So that is why Newton failed in explaining the velocity of sound, because he has considered isothermal expansion. Temperature is constant. So here E is taken as the bulk modulus for gases, which is taken as the P isothermal, that is pressure of the air, 10 power 5 pascals, and density is 1.29. Substituting, you are getting 280 meters per second velocity. So this was little wrong value. Later another scientist came forward called as Laplace. Okay, so he is given the correction value for this one. Okay, let us see that value. Laplace correction. Another 5 minutes I'll end up this part 2. This is part 2 of sound chapter. I think remaining part will be dealing in the part 3 only, the last part. Okay, so Laplace corrected the value. That is called as Laplace correction. So another scientist is called adiabatic expansion. Adiabatic expansion. You know, in adiabatic, dq is equal to 0. No heat will be coming inside, no heat is going out, just like refrigeration. Okay, it is completely closed. dq is equal to 0. So Laplace ఏం చేశాడు, velocity కి ఆయన root over, okay, yes, another term. ఇందాక ఏదైతే root over b by d ఉందో, bulk modulus by density ఉందో, this is taken as, of course it is taken as b. Bulk modulus is taken as p, gamma p by rho. Laplace ఏం చేశారు, చిన్న కరెక్షన్ ఇచ్చారు. ఏంటి గామా, రేషియో ఆఫ్ స్పెసిఫిక్ హీట్ ఆఫ్ గ్యాసెస్, molar specific heat, Cp by Cv, and not only that, gamma is equal to 1 plus 2 by F, where F is the degree of freedom already I have dealt in thermodynamics. For monoatomic gases under normal condition 3, diatomic 5, and polyatomic 6, and a high temperature vibration mode low 3 plus 2, 5 plus 2, 6 plus 2. Clear? So you can put this equation here. Laplace ఏం చేశారంటే root over is taken for generally nitrogen gas N2, the diatomic, degree of freedom is 5. So when you put the value here 5, ఎంత అవుతుంది, 5 plus 2, 7 by 5, that is 1.4 gamma N2 gas. So when you substitute here gamma 1.4 into pressure, again value, pressure of the air, P is nothing but pressure of the air. How much? 10 power 5 pascals. Okay, 10 power 5 pascals by density again 1.29 kg per meter cube, density of air. After substituting all the values, Laplace has got very nice value, that is 332 meter per second, and this value was accepted. We even in numericals were taking 330 meters per second or sometimes 340 meters per second. So this is the corrected value, because we all know here gamma is another term is coming, extra term, ratio of specific heats, because he has considered the adiabatic expansion. And for diatomic gas, because N2, the nitrogen gas, diatomic kabatti, the degree of freedom 5. So when you substitute here, whatever 2 by 5, that is 7 by 5, that is 1.4. Putting the value of pressure, okay, that value is 10 power 5, and density of the air 1.29. Laplace got exact value, nearly, that is 332 meters per second. And this, if you compare with Newton's, it is 280. That means very large difference is there for the velocity of sound. So this is accepted now. Okay, so this is how we will be explaining the speed of sound waves by Newton's method and Laplace method. Okay, now the remaining part, that is next part, that is organ pipes, I will be dealing in part 3 of sound waves. So this is part 2. In part 3, I will be dealing about the organ pipes. Okay, I think one thing I forgot to tell before leaving my class. One more formula is left over. I'll give that formula and that end up. Small formula is left over. After that I'll end up. See, in this Laplace connection, connection only. In this Laplace connection, one more formula I will be adding for this one. We know for ideal gas equation, PV is equal to nRT. What is small n? Number of moles. That is small m by capital M. Mass of the gas in grams by gram mole per weight. So if you substitute here, PV is equal to small m by capital M RT. And from this, what is density? Density is mass per volume kada. So in the range, what is mass per volume? Already in KTG, kinetic theory of gases, I told you. So PM by RT is equal to density. That is equal to M by V. So substitute here. Laplace correction V is equal to root over gamma P by E rho density lo em pettali PM by RT. PM by RT. That is equal to root over gamma P PM RT paiki vellipotundi RT. PP gets cancelled. So velocity is given by root over gamma RT by capital M. Gamma 1 plus 2 by F, degree of freedom depending upon the gases. R, gas constant 8.314 joule per mole degree Kelvin. Gas constant, universal gas constant. T, absolute temperature, that is Kelvin temperature. Kelvin temperature, absolute temperature 273 plus degree centigrade. And M is gram molecular weight. Gram molecular weight of the given gas. So this formula is used for when absolute temperature and gram molecular of weight of a gas is given. For example, when you compare with different gases like helium gas, nitrogen, then you have to use this formula. Otherwise, the above formula. Clear? So with this, I'll end up this chapter. In part 2, not end of this chapter, in part 3 of sound, the remaining part, organ pipes, ratios, okay, beats, echoes, Doppler effect will be completing in part 3 of sound waves.